This is the initial problem for velocity and position. Very classical problem here. So we suppose that we know the velocity of an object. At this time, we are going to consider just the movement along a straight line, so that it's just one-dimensional move. Then its position can be found by solving this initial value problem. So it's when s is position, the derivative of position is actually the velocity. So to find the position, this is the differential equation that we need to solve. The initial condition is when time is 0, its position is in its initial position as 0. Similarly, if the acceleration is given, then we can find the velocity by solving this initial value problem. The derivative of velocity is the acceleration, and that when time is 0, the initial velocity is v0, so which is the initial velocity. Now let's look at the problem 8. So here, suppose runner A begins at this position point s0 equals 0 and runs with the velocity v equals sine t. And runner B begins at the same position and runs with velocity cosine t. Let's find the position functions of both runners. So let's say s sub a should be the antiderivative of its velocity, which is sine. How about we write the velocity function first? So va of t dt, right? So this subscription represents this is for the runner A, equals antiderivative of sine t dt, which is negative cosine t plus a constant, let's call it c sub a. And we do know s of 0 is equal to 0, which means negative cosine 0 plus c sub a should be equal to 0. And cosine 0 is just 1. So here we get negative 1 plus c sub a is equal to 0, which means c sub a is just 1. Now, from here we do know the position of runner A. It should be equal to 1 minus cosine t, because c sub a is just 1. For runner B, we do the same. So find the antiderivative of the velocity, which is the antiderivative of cosine t. It gives us sine t. Now, again, don't forget that you have to always add the constant. So let's call that as c sub b. And then we do know that the initial condition is s of 0 equals 0, which means sine of 0 plus c sub b is equal to 0. And sine of 0 is 0, which means c sub b is just equal to 0. So therefore we do know s sub b, the position for runner B is going to be sine t. That's it. So if you graph the both position functions on the same graph, 1 minus cosine t looks like this. Okay, 1 minus cosine t looks like this. And this is from 0 to, this is gonna be 2 pi. And sine t, of course, looks like this. This is sine t. Here, this value is 2, this is just 1, this is -1. So this is for the runner B, and this is for runner A. Okay. Now let's find the time and position at which they first pass each other. We can actually see from the graph, this is position function. At that moment, that's when they are at the same position. So that's when the green, which is my A, passes the blue, which is the B. Let's find it using algebra. So when they first pass each other, so they must have the same position function, which means 1 minus cosine t should be equal to sine t. One way to solve this equation is to, you don't want to see two different functions. You want to convert it into the same, either converts cosine to sine or sine to cosine. So here's the trick that I have. I'm gonna square both sides. When I square both sides, the left side is 1 minus cosine t squared. The right hand side is sine t squared. And from the left, you have 1 minus 2 cosine t plus cosine t squared. And the right side is 1 minus cosine t squared, right? No points to convert cosine to sine. It's easier to convert sine squared t to 1 minus cosine t squared. Now let's simplify this one. We can see that 1 and 1 cancel, and we're left with minus 2 cosine t. Now when we move the right hand side to the left hand side, negative cosine t squared becomes positive to cosine t squared, so we have 2 cosine t squared here. And we also have another minus 2 cosine t here. So minus 2 cosine t here equals 0. Let's try to, first of all, we can divide both sides by 2, get rid of the 2, and then factor out the cosine t. So we're left with cosine t minus 1 equals 0, which means cosine t equals 0, or cosine t minus 1 equals 0. From cosine t equals 0, we do know that t is equal to pi over 2. So that seems to match our graph. You would probably know that this point is actually the pi over 2. That's when they meet. When cosine t minus 1 is equal to 0, which means cosine t is 1. When cosine t is 1, t is equal to pi, right? I mean, t is equal to 0 or 2 pi. So t is equal to 0 or 2 pi. But 2 pi is the end point here. We know that that's not the solution. So therefore, the first time they pass each other is t equals pi over 2.